Ever wondered if humans could traverse the seemingly infinite expanse of space, reaching far beyond our own solar system? The very notion of interstellar travel teems with fascination and curiosity. It's a concept that's both thrilling and daunting as it touches upon the very limits of our understanding and capability. To appreciate the enormity of this idea, let's consider the vastness of interstellar distances. Imagine, if you will, that our entire solar system was the size of a coffee cup. In this scenario, the nearest star system, Alpha Centauri, would be another coffee cup 2 miles away. That's right, 2 miles. This immense distance puts into perspective the sheer scale of space and the enormity of the challenge that interstellar travel presents. So the question arises, could astronauts survive the journey to another star system? To contemplate the possibility of interstellar travel, we need to understand a few scientific principles. First, let's talk about space-time. Picture a sheet of fabric stretched taut. This fabric represents the universe, and the objects on it, like stars and planets, cause it to warp and curve. That's space-time, the four-dimensional fabric of the universe that Einstein described in his theory of relativity. Now imagine a beam of light traveling across this fabric. Light doesn't just travel in a straight line, it follows the curves and dips created by the massive objects. And it always travels at a constant speed, about 186,000 miles per second, which we call the speed of light. This brings us to our next principle, light years. A light year is not a measure of time but distance. It's the distance that light, traveling at its constant speed, can cover in a year. That's almost 6 trillion miles. When we say a star is 4 light years away, we mean that the light we're seeing from that star today actually left that star 4 years ago. So, how does all this relate to interstellar travel? Well, the vast distances between stars mean that even at the speed of light, it would take years to reach even the closest star systems. For instance, Proxima Centauri, our nearest stellar neighbor, is over 4 light years away. So if we could travel at the speed of light, it would still take us 4 years to get there. But here's the kicker. As per Einstein's theory, as we approach the speed of light, time slows down. This is known as time dilation. So, for our hypothetical space travelers, the journey might seem shorter. Yet for those left behind on Earth, years would have passed. These principles form the scientific foundation of interstellar journeys. The sheer scale of the universe, the constant speed of light, and the warping of space-time all combine to make interstellar travel a fascinating, yet daunting prospect. It's a journey not just through space, but also through time, and one that challenges our understanding of the very nature of reality. Embarking on an interstellar journey is not without its challenges. This statement extends far beyond the realms of mere speculation and into the very heart of our understanding of space travel. One of the most formidable obstacles is the sheer span of time it would take to travel between stars. Even at the speed of our fastest spacecraft, Voyager 1, which clocks in at over 17 kilometers per second, reaching the nearest star to our solar system, Proxima Centauri, would take over 70,000 years. That's longer than the entire history of human civilization. Then there's the matter of weightlessness. While it may sound fun to float around a spacecraft, the long-term effects of weightlessness on the human body are far less amusing. Astronauts in space experience muscle and bone loss, vision impairments, and a weakened immune system. This is because our bodies have evolved under Earth's gravity and are not equipped to handle extended periods of weightlessness. Now let's talk about cosmic radiation. Unlike on Earth, where our atmosphere and magnetic field shield us from much of the solar and cosmic radiation, in deep space, astronauts would be exposed to significantly higher levels of radiation. This can lead to a host of health issues, including an increased risk of cancer and damage to the central nervous system. Even the psychological challenges of interstellar travel cannot be ignored. The isolation and confinement, the monotony of a long journey, and the constant danger can take a significant toll on an astronaut's mental health. In essence, interstellar travel isn't just about building a faster spacecraft. It's about understanding and overcoming the multifaceted challenges that space presents to the human body and mind. It's about pushing the boundaries of human endurance and technological capability, and it's about finding solutions to problems we're just beginning to understand. Overcoming these obstacles is key to making interstellar travel a reality. As we continue to explore the possibilities, we're not just reaching for the stars, we're learning how to survive the journey. Scientists and engineers are working tirelessly to find solutions to these challenges. Indeed, the riddles of interstellar travel are as complex as they are intriguing, but that doesn't mean they're unsolvable. Let's delve into some of the proposed solutions that might help us conquer the vast distances of space. First off, we have the idea of cryogenic sleep, often referred to as suspended animation. This involves decreasing the body's metabolic rate to a near standstill, allowing astronauts to survive potentially centuries-long voyages. However, as exciting as it sounds, it's a concept that currently resides within the realms of science fiction. The technology to safely freeze and revive a human being is yet to be perfected. But, with continued advances in medical and technological fields, who knows what the future holds? Next, there's the concept of generation ships. These are essentially self-sustaining spaceships designed to support multiple generations of humans. The idea is that the descendants of the original crew would be the ones to reach the destination. This solution bypasses the issue of human lifespan, but brings with it a whole host of social and psychological challenges. Would a society born and raised in the confines of a spaceship be willing or even able to settle on an alien world? Finally, there's the prospect of faster-than-light travel. This is the holy grail of space exploration, the ability to traverse light years in a matter of weeks or even days. Concepts like warp drives and wormholes are tantalizing, but they currently exist only in the equations of theoretical physicists. Turning these theories into practical functioning technologies is a monumental task, and one that might not even be possible. While these solutions might seem like science fiction, they might just be our ticket to the stars. So, as we stand on the precipice of a new era of space exploration, remember that today's science fiction could be tomorrow's science fact. It's a long, tough road ahead, but one that holds the promise of unimaginable discoveries and advancements. Interstellar travel is a grand and complex concept, but let's summarize our journey today. We embarked on an exciting exploration of the enigma of interstellar travel, delving into the science that underpins this fascinating subject. We discovered that interstellar travel involves traversing the vast, seemingly infinite cosmic distances between stars, a feat that requires speeds beyond our current capabilities, and a journey time that stretches into thousands of years. We delved into the science behind it all, discussing the principles of physics that could potentially enable such a journey. We talked about the concept of a warp drive and how bending space-time could theoretically allow us to bypass the universal speed limit set by light. We also explored the idea of wormholes, gateways through space-time that could offer shortcuts across the vast cosmos. The journey, however, is not without its challenges. We discussed the physical and psychological toll of long-duration space travel on the human body and mind. The harsh environment of space, the isolation, and the sheer longevity of the mission pose significant hurdles that we must overcome. We also looked at the technical challenges, such as the need for sustainable life support systems, and the daunting task of creating a propulsion system capable of reaching the necessary speeds. Yet, despite these challenges, we also explored potential solutions that could make interstellar travel a reality. From generation ships to cryogenic sleep, we discussed how these innovative ideas could potentially mitigate the challenges of long-duration space travel. We also discussed the potential of harnessing the power of antimatter and how science fiction might become science fact. While the road to interstellar travel is fraught with challenges, the human spirit of exploration and innovation continually pushes us towards the stars. So, could astronauts survive interstellar travel? With time, research, and a bit of luck, the answer might just be yes.